In this lesson, we'll continue a review of Math Test 7, Section 3, No Calculator, questions 5 through 8. So still relatively early on, not too difficult, these problems. Let's take a look at number 5. We have a function question. What is f of negative 1? So here's the original function, f of x. And now we're asked to solve f of negative 1. Whenever we see an x, we replace it with negative 1. And so here's an x, that's negative 1 squared minus 6, another x, so times negative 1 plus 3, another x, so that's negative 1 minus 1. And now we just simplify. Negative 1 squared, that is 1. Negative 6 times negative 1, that's plus 6, plus 3. And that's the numerator, so that equals 10. And negative 1 minus 1 is negative 2. 10 divided by negative 2 is negative 5a. All right, let's take a look at number 6. A company that makes wildlife videos purchases camera equipment for $32,400. The equipment depreciates in a value at a constant rate for 12 years, after which it is considered of no monetary value. How much is the camera equipment worth 4 years after its purchase? This is just linear, straight line depreciation. And this question I don't think is difficult, but it takes a little bit of arithmetic, and this is the no calculator section. So we have to realize it starts out at 32,400, depreciates literally 12 years until it has zeros. So we can figure out the annual depreciation. And again, you just have to work this out. And so I'll do it with you. So 12 into 32,400. So let's see, 12 times 2 is 24. And then we get 84. Helps if you know your times tables. 12 times 7 is 84. This is 0. We bring down a 0. We add a 0. We bring down another 0. We add a 0. It's 2,700 annually. But now we have to multiply this by 4. We know that 4 times 2,500 is 10,000. 4, and so we have 200 more times 4. That'd be 800. Again, you could do it the long way, but try to look for shortcuts. It's 10,800 is the total amount of depreciation. That's 2,700 times 4. We're starting at 32,400, and we're depreciating by 10,800. So 10,800 is pretty close to 11. If we just subtracted 11,000, we'd end up with 21,400. But we've got to add back the 2 because it's not quite at 11. It's at 10,800. And so the answer is 21,600. Again, look for shortcuts. Not a hard question, but just be careful with your arithmetic. All right, let's take a look at number 7. Here we have an equation. Which of the following is equivalent to the expression above? And the key here is if you look at A and B, these are both the same quantities. And then we have C and D. I would just, once you do x plus 3, you don't have to do it again for B. And the same, once you do x minus 3, you don't have to do it again. And so let's just do x plus 3. Remember, this is the quantity squared, so that's x plus 3 times x plus 3. We're going to FOIL this out. We get x squared plus 3x plus 3x. Those are the middle two terms. We get plus 6x plus 9. And so this is the first term. And we want to get this. And this is pretty close, but instead of a 4, we have a 9. And if you look at this, though, B would be the answer, right? If we just subtract this whole quantity and we just subtract 5, we're going to end up with x squared plus x plus 4. You don't need to do these bottoms. If none of these two worked, you'd have to do this and then check. But the answer here is B. All right, one last question on this page. It's number 8. Ken is working this summer as part of a crew on a farm. He earned $8 per hour for the first 10 hours he worked this week. Because of his performance, his crew leader raised his salary to $10 an hour for the rest of the week. Ken saves 90% of his earnings from each week. What is the least number of hours he must work the rest of the week to save at least $270 for the week? All right, so a little bit of a bulky question. He needs to save 270, and he saves 90% of his earnings. I think this would be really helpful. I'm going to show you a couple ways to do this problem, but if you can recognize what's the total amount he has to work. So this is 90% of 270. If you could just think about 270 equals 0.9x to get the total number of hours. Another way of doing this is just 270 divided by 0.9. Now I know it's no calculator, but 9 goes into 27 3 times. And have to add a 0 and another 0 because of the decimal. It's going to be 300. This is, I think, really helpful if you recognize that he needs to get $300 in earnings. That is 90% equals to 270. 0.9 times 300 is 270. So I think that's the first step. So again, there's a couple of ways to do this problem. One way is just a straight algebraic way, and $8 an hour for the first 10, both of these are given. And so 8 times 10, we know it's $80. That's given. That's static. It's not going to change. But we don't know how many extra hours he worked at $10 an hour. Remember, that's his raise. And so we're going to do 80 plus $10 an hour times those number of hours equals 300. Now, again, if you didn't get that 300, what you could also do is you have to recognize that this whole amount is 0.9, and that would be 270. But either way, you're going to get the 300 because you divide by 0.9. So again, that's really the key, is recognizing 300 is the total amount he has to make because 90% of that is 270. And so at this point, once we divide the 0.9, we get 80 plus 10x equals 300. We subtract 80 and we get 10x equals 220, and x is 22. The answer is C. Another way of doing this, instead of doing this equation, is, again, if you recognize it's 300, so you just have to say to yourself, I know he has to make $300. He already has made 80. That doesn't change. We know whatever the remaining hours will be multiplied by 10. You could just use the answers, and you could see you could just take 22 times 10, and that's 220, and that will get you at that 300. So again, a couple of ways to solve this. Is sort of an intuitive method, the second way. But these types of questions, you just have to be pretty proficient at understanding percentages, and this is the equation, but just realizing that if you're really working backwards with a percentage. We know he has to save 300, so 270 we divide by 0.9, and that will give us that ending result.